Hello everyone, today I will discuss the zero and negative exponent of an exponential expression. Let's start with zero exponents. First, let us define what is a zero exponent. We have here, if x is raised to 0 then it is equal to 1. Where x is not equal to 0. Wherein any number excluding 0, with an exponent of 0 is equal to 1. Example. We have here 3 raised to 0. As the definition of zero exponents states that any number excluding 0 is equal to 1. Therefore, 3 raised to 0 is equal to 1. Another example. 10 raised to 0 plus 5 raised to 0 plus 11 raised to 0, and plus 3 raised to 0. First, let us simplify each number that raises to 0. So, we have 10 raised to 0 is equal to 1. Plus 5 raised to 0 is equal to 1. Plus 11 raised to 0 is equal to 1. And 3 raised to 0 is equal to 1. After we simplify, let us now get their sum. We have 1 plus 1, and plus 1. Then, the sum is equal to 4. That is now the answer. Another example is 3 raised to 4 multiplied by 5 raised to 0. First, before we multiply let us simplify 3 raised to 4. The simplified form of 3 raised to 4 is 81. How? It is just multiplying 3 itself 4 times. So, we have 3 times 3 is equal to 9, then, 9 times 3 is equal to 27, and lastly, 27 times 3 is equal to 81. That is the value of 3 raised to 4. Next, let us also simplify 5 raised to 0. 5 raised to 0 is equal to 1. Then, let us now get their product. 81 times 1 is equal to 81. That is now the answer. Let us have the last example. We have 2 raised to 3 over 2 raised to 3. Since the base is similar, then, we just write only the 2. Since the operation is division, the exponent will subtract. So, we have 2 raised to 3 minus 3 is equal to 2 raised to 0. Therefore, 2 raised to 0 is equal to 1. That is now the answer. These are some examples of problems that have a zero exponent. We were done with zero exponents. Let us move now to the negative exponent. Here is the definition of negative exponent. If x is raised to negative n, then it is equal to 1 over x raised to positive n. And if x is raised to positive n, then it is equal to 1 over x raised to negative n. Where x is not equal to 0, and n is a counting number. Bear in mind that, in simplifying exponential expression, always in the form of the positive exponent. Let us have an example. May we have 2 raised to negative 3. To simplify this expression, we need to turn the negative exponent into a positive exponent. By applying the definition of negative exponent. If we want the negative exponent to be positive, make the number into fraction form and find its reciprocal. By making the numerator by the denominator, and the denominator is the numerator. For instance, if there is 5 as a number, then, the fraction form of 5 is 5 over 1. If you want the reciprocal of 5 over 1, the reciprocal is 1 over 5. By performing the reciprocal process for the number that has an exponent, then, the exponent of a number will be affected by changing its sign. If the number has a negative exponent, then it turns into a positive exponent, and vice versa. Let us go back to the example, which is, the 2 is raised to negative 3. As you can see it has a negative exponent. We need to turn the negative exponent into a positive exponent. By doing the reciprocal, the 2 raised to negative 3. Then, it becomes 1 over 2 raised into positive 3. This is how to make a negative exponent into a positive exponent. Since we need the simplified form, then, we need to do another simplification. The 2 raised to 3 is equal to 8. By getting a product of 2 times 2, then times 2 is equal to 8. Then 1 over 8 is the answer. Let us have another example. 1 over 3 raised to negative 4. First, let us make the negative exponent into a positive exponent. By getting its reciprocal, the numerator becomes the denominator, and the denominator becomes the numerator. So, we have 3 raised to 4 over 1, or simply 3 raised to 4 is equal to 81. By simply getting the product of 3 times 3 is equal to 9. Then, 9 times 3 is equal to 27. And lastly, 27 times 3 is equal to 81. Then, 81 is the answer. Another example. We have x raised to negative 2 multiplied by y raised to 1 open and close parenthesis, raised to 4. First, we need to distribute the 4 in each exponent in the parenthesis. We have 4 multiplied by -2. The result is x raised to -8. Then, 4 multiply y raised to 1. Then, the result is y raised to 4. So, we have x raised to -8, and y raised to 4. Then, we need to transform the negative exponent into a positive. So, we have 1 over x raised to 8, multiplied by y raised to 4. Then, we need to multiply y raised to 4 into the numerator, which is 1. Then, the result is y raised to 4 over x raised to 8. That is now the answer. May have the last example. X raised to -2, open and close parenthesis, raised to 3 multiplied by y raised to 3, over y raised to -2. First, let us remove the parenthesis by distributing the 3 inside of the parenthesis. We have x raised to -6, multiplied by y raised to 3, over y raised to -2. For you to clearly see and understand the process, I expanded the expression. So, we have x raised to -6, multiplied by y to raise 3, and multiplied by 1 over y raised to -2. Let us simplify x raised to -6. Then, it became 1 over x and raised to +6. Multiplied by y cubed, multiplied to the reciprocal of 1 over y raised to -2, to simply y square. Then, we have 1 over x raised to 6, multiplied by. Since they have the same base which is y. Then, I just copy y. Since the operation of both y is multiplication. Then, we perform addition on their exponents. Therefore, we have 3 plus 2. Then, we have 1 over x, raised to 6. Multiplied by y raised to 5. Then, to make it more simplified, we multiply y raised to 5 in the numerator, which is 1. Then, the result is y raised to 5 over x raised to 6. That is now the answer. Will you try this exercises? The answer will reveal at the end of the video.
For more videos on mathematics, please don't forget to subscribe.